Hello and welcome to Science 117, Lab Assignment 4, Part 2. I'm Shane. I've chosen to do my lab assignment on electrolysis. I always have a interest in electrical applications, and this one in particular involves the electrolysis of water, which is breaking apart the hydrogen and oxygen atoms, turning them into hydrogen and oxygen gas. I think this is a very efficient process, and it's going to be very beneficial to our planet when they find a more suitable power source, a greener power source. Once they do this, it'll help with the greenhouse gases. So let's look at the lab. So to do this, we basically take an electrolyte in water and we run electrical current through it. So I tried different solutions. I tried sodium bicarbonate, I tried salt, and I tried sodium hydroxide. So what I found out best is sodium hydroxide worked the best. Electrically, through the process, it's much harder and takes a much higher voltage to break that element down. So at first I used push pins, metal push pins, and with the salt and the baking soda, they corroded they oxidized the electrodes, and you can see they took some of the metal out. So that was a product of the salt and the sodium baking soda. So basically what's going to happen is the hydrogen atoms are going to gather on the cathode, which is the negative part of the battery. The oxygen atoms are going to gather on the anode, which is the positive side of the battery. So this is my solution, and we'll pour this in, and you'll see the bubbles come off the electrodes. That's the hydrogen and oxygen gas being broken apart. It's the water being broken apart into hydrogen and oxygen gas through the electrolysis process by a chemical reaction called redox, which is reduction and oxidation. Now, if I were able to dip the test tubes in the solution, which I'm not because this is drain cleaner, and put these over top of the electrodes, you would notice that the water would be pushed down twice as far on the cathode side than it would the oxygen side. Supposedly this is how they found out there were 2 atoms of hydrogen in water and 1 oxygen, because the gas, there's twice as much gas that it produces. So you can see on the right side, that is the hydrogen, and the left side was the oxygen gas. So let's look how this happens. So through the chemical reaction called redox, reduction and oxidation, we take water, H2O, and through the process, we break it apart and we make H2 and O2. It's O2 because these are diatomic elements and they come in twos. These two and several others. So the law of conservation of mass basically says mass is neither created nor destroyed in a chemical reaction. So essentially it's equal on both sides. So we multiply this side by 2 and we get 2H2O and 2H2 plus O2 on this side. So let's look at what's going on, see how this has happened. We'll look at the half reactions. So we have the 2 H2Os, the water molecules, and on a reduction gains electrons. So this process is gaining electrons here and breaking off the hydrogen atoms. It leaves us with 2 hydrogen atoms and 2 hydroxides. So that's 1 oxygen and 1 hydrogen. So the formula will look like this: 2H2O plus the 2 electrons it gained yields 2 hydrogens, H2, plus 2 hydroxides. If we look at the oxidation, same thing, 2 water molecules yields 2 oxygen. Notice these are the oxidation numbers. It lost 2 electrons. And then we end up with 4 hydrogens. So our equation here looks like 2H2O minus 4 electrons, because it lost 4 electrons, yields O2 plus 4 hydrogens. Now on these equations we can't have the minus 4. So we add 4 to this side and add 4 to this side. So it's O2 H4 plus 4 electrons. So if we look at the reduction formula, we have 2H2O plus 2 electrons yields the 2 hydrogens and the 2 hydroxides. On the oxidation end, we end up with 2 water molecules yielding the O2 plus 4H plus the 4 electrons. So we have 4 electrons here and 2 here. We need to balance that out. We multiply this by 2. We get 4H2O plus 4 electrons plus 2H2O yielding 2H2 plus 4 hydroxides plus O2 plus 4 hydrogen plus 4 electrons. Well, these will cancel each other out. This side leaves us with 6 waters and 2H2 plus the hydroxides and the hydrogens make water. So that's plus 4 H2O plus O2. Now we can get rid of the 4 waters here and get rid of them over here. That leaves us with 2 H2O yielding 2H2 plus O2, the equation we started with.